So in part B on this question, we're told the jewelry company wants to make sure that the machines work properly. So we have Cleo, a statistician that performs tests every day. He uses a random sample of size n equals 2. And we're told Cleo starts by considering the mean amount of gold being applied to the necklaces after taking 2 necklaces. We're told that suppose the machine is working properly with a mean of 300 milligrams and standard deviation of 5 milligrams. We need to calculate the probability that the sample mean amount of gold applied to n equals 2 will be greater than 300 milligrams. So we need to find the probability of this variable being 300 larger than 303. So again, we can convert this into a standard normal distribution. So z has to be larger than 303 minus the mean divided by the new standard deviation. Since we have a sample of 2, we divide 5 by the current standard deviation by the square root of the sample size. So we get the probability of z being larger than 0.8485. And for this, we will get 0.198 from the table provided. We're told in part 2, suppose Cleo took a random sample of n equals 2 necklaces that resulted in a sample mean amount of gold applied of 303 milligrams. Would that result indicate that the population mean amount of gold applied is different from 300 milligrams? Justify your answer without performing any inference procedures. And well, no, it would not provide significant evidence. Provide evidence. And the reason for that is because the probability of having a sample that differs from 300, so we have the probability of observing a sample mean that differs by 3 milligrams. From 300 milligrams, obviously, is pretty large. So it's normal that if we get something like 303 milligrams, that's not really an issue here. That's somewhat normal. In fact, if we can calculate the precise value, we simply need to take the probability that we have calculated and multiply it by 2 to get 0.396, because we can differ in the negative or positive way from 300. This is no concern.